Hello everyone, it's a pleasure to be here today. I am Mace and today I want to share with you a short overview of my garden generator completely done within the Unreal PCG framework. The garden generator at its core operates on two spline components, the edge spline and the path spline. Additionally, I leverage packed level instance. For those unfamiliar, packed levels function like prefabs, allowing you to create a container that holds geometry, which can then be instanced throughout the level. Within the first component, we are using just the edge spline to place the border walls and the basic ground coverage. Based on a curvature filter, I place either a straight or a rounded wall level instance. This method is not only efficient, but also very flexible within PCG, as we can tag, filter, and modify meshes inside each instance after they got placed. For example, here you can see what I do after the curvature filter with the place straight wall. I filter for the tagged shrubs only and mask them out wherever the stairs bounding box is overlapping while keeping the straight stone wall. Every shrub which is still placed is then randomly transformed a bit to give more variations across the board. Let's move on to the flower scattering. For this component, I'm using the edge spline and the path spline. First, I delete all the points which are inside the spline bounding box. Then I compute the distance to the path spline on the surface, which we can visualize as a density here. With this density information, I can now instance different flower categories. I have three flower categories, white, red, and purple. By aligning the height of the spline, I can define the flower type, but also the scale based on their distance attribute towards the spline. Let's move on to the stair component. Here we are using the edge spline and the path spline. First, I filter out all overlapping points of those splines. These filtered points are then injected into a custom PCG blueprint, which acts like an attribute transfer node. Since the setup has never been shown before, I would like to walk you through what it requires to make such a custom blueprint. It's getting a bit technical, please bear with me. First, we have to set up and declare the input data information. I have two input pins, the border and the path points. Then we have to initialize and store each point data. This process is what Epic defined as a boilerplate setup, which is needed for any kind of point data manipulation. Now I want to get the closest point. First, I get all vector position for each border point, as you can see in the top right. After that, I run through each point on the path and check the distance against the stored border point position. This is how the blueprint looks inside. I define the max search radius and test for each vector the distance. Only one point will be the closest, and I get the corresponding index value of this point and store this index inside a new array on the same looping index of the path point. After this, I can finally loop over each target point data. I get the length of the target point array as the number of my iterations. After this, I can finally loop over each target point data. I get the length of the target point array as the number of my iterations. Now we are in the loop body. For each path point, I get the corresponding closest index as stored before. I then check the orientation axis of these with a dot product. We can visualize that nicely with an Unreal debugger view. On the left, we can see how the red x-axis on the border points are orientated in the opposite direction as the path points. If the dot product is negative, I will flip the rotation on the jaw about 180 degrees. Then I have to make the actual new point data and output it. For all points, I set the closest point location on the border spline, and depending on the dot product, I flip the jaw. Let's see it in action. We can now draw the path spline, and on the edge where the splines are overlapping, we are automatically placing the stairs using the jaw rotation of the path spline. That gives a nice alignment with the flow of the path. That was quite a ride for an attribute transfer points loop. And at this point, I was wondering how I would do the setup within Houdini. So I made a small test. Everything you just saw in the custom blueprint setup fits within this attribute wrangle, which is very handy. I'm using the XYZ list together with the PrimUV functions and do the same dot product check to align the stairs. Alright, let's go briefly over the last component. The main concept here is that I solve for intersections and use a mesh array to instance different type of stone paths. Afterwards, I step rotate them to give a nice variation. As my time is running out, I would refer here to the 80-level article about the system, where I explain more about the custom blueprint setup for this component. I want to wrap it up with 2 tips. If you want to learn more about custom blueprint setups, I can recommend the folder BP Elements inside the PCG plugin, which still contains all the initial custom blueprint setups made by Epic Games for the Electric Dream sample. Especially the deprecated folder is very useful to learn from. And another material trick, the speed3 color variation function, which is standard in Unreal, can be used to get a nice variation across different instance static meshes. Thank you for listening. Please feel free to reach out to me on LinkedIn, and if you have any questions, let's have a chat later.